There are places on Earth where the rulebook of reality seems to get thrown out the window. We're talking about lakes that turn the color of blood, stones that slide across the desert on their own, and phantom lights that dance in the dark. For centuries, these bizarre happenings were the stuff of myths and nightmares blamed on ghosts, angry gods, and ancient curses. But what if the real story is even stranger? Today, we're pulling back the curtain on the supernatural to uncover the mind-bending science behind the world's most haunting phenomena. We'll find that fact is often far more fascinating than fiction. Our journey begins in one of the most desolate places on the planet, Death Valley, California. Here, on a dried lakebed called Racetrack Playa, lies a puzzle that has stumped scientists for decades. Rocks, some weighing hundreds of pounds, appear to move across the flat desert floor by themselves, leaving long, carved tracks in the cracked mud. For years, nobody had ever seen them move. The rocks would just appear in new spots, their trails stretching out behind them like silent, ghostly breadcrumbs. Theories ranged from magnetic fields to hurricane-force winds to, of course, aliens. It was even noted that stones with rough bottoms seemed to leave straight tracks, while smoother ones wandered, which only deepened the enigma. Finally, in 2014, after years of theories, a team of scientists captured the whole thing in action. Their experiment, using GPS-tagged rocks and time-lapse cameras, was jokingly called the most boring experiment ever, because the stones might not move for a decade or more. But their patience paid off. They discovered the movement isn't driven by one single force, but a perfect, delicate conspiracy of nature. Here's the recipe. First, the playa needs just enough rain to create a shallow pond, only a few inches deep. Then, on a cold winter night, that water freezes into a thin sheet of window pane ice, which traps the rocks. As the morning sun warms the playa, the ice starts to melt and break up into huge floating panels. This is where the magic happens. All it takes is a light breeze, barely 10 miles per hour, to start pushing these massive ice sheets across the slick, muddy floor. The ice acts like a slow-motion bulldozer, shoving the rocks in front of it at about the pace of a crawling baby. It's not a ghost, but a fragile combination of water, ice, and wind, performing one of the quietest and most beautiful ballets on Earth. Now, imagine you're near a swamp late at night. In the distance, a faint, flickering blue light dances silently over the water. As you step closer, it seems to float away, luring you deeper into the darkness. This is the willow, the wisp, also known in folklore as ignis fatuus, or foolish fire. For centuries, these ghostly lights were believed to be mischievous spirits or lost souls trying to lead travelers astray, appearing in legends from Scotland to Japan. For a long time, science had a partial explanation. Swamps are full of decaying organic matter that releases flammable gases like methane, what we call swamp gas. The idea was that this gas would somehow catch fire, creating the floating flames. But there was a huge missing piece. What's the spark? Methane doesn't just spontaneously burst into flame in cool, damp air. This is where the story gets really interesting, because science still doesn't have a single confirmed answer. It remains a genuine mystery with several competing theories. One of the oldest and most popular ideas involves a gas called phosphine. When mixed with another phosphorus compound, diphosphane, it can ignite spontaneously on contact with oxygen in the air. This small ignition could then be enough to light the much more abundant methane. A more recent and stranger idea has been explored in labs at Stanford University: microlightning. Experiments suggest that as tiny bubbles of methane rise through water, they can generate powerful electric fields. When two bubbles get close, a tiny sub-millisecond spark can jump between them just enough to ignite the methane and create a faint, cool flame. So, while we don't know for sure if it's spontaneous chemical reactions or millions of tiny, sparking bubbles, the legend wasn't entirely wrong. It really is a kind of fire. But the spark isn't from a ghostly lantern, it's from the hidden physics and chemistry of the swamp itself. On certain nights, in certain corners of the world, the ocean puts on a light show that's nothing short of magical. Waves crash against the shore not in white foam, but in a brilliant, glowing blue. Footprints in the wet sand sparkle, and a boat's wake leaves a shimmering trail of liquid starlight. This stunning phenomenon is called bioluminescence, and its origin is entirely biological. The glow comes from massive blooms of single-celled organisms called dinoflagellates. Think of them as microscopic algae, and when millions of them gather in a single drop of water, they have the power to transform the sea. So why do they light up? It's a defense mechanism often called the burglar alarm effect. When a dinoflagellate is disturbed by a crashing wave, a hungry fish, or even your foot, it sets off a chemical reaction inside its cell. The reaction between a chemical called luciferin and an enzyme, luciferase, creates a brilliant flash of cold blue light. The flash is meant to startle a predator trying to eat it. But there's an even cleverer trick at play. The light can attract a bigger predator, which might then eat the creature that was threatening the dinoflagellate in the first place. It's a microscopic scream for help, lighting up attackers for everyone to see. These tiny organisms even follow a daily rhythm, just like we do. They only produce their light-emitting chemicals at night, saving energy during the day. That's why you can only witness this spectacular display after the sun goes down, turning an ordinary beach into an alien world. It's incredible to think that something so magical is caused by creatures too small for the human eye to see. The natural world is full of hidden wonders, and if you're enjoying uncovering the science behind them, go ahead and subscribe and hit that notification bell. We have a lot more mysteries to explore together. From glowing blue, we turn to a sinister crimson. Around the world, there are lakes and lagoons that can turn a shocking blood-red color under the right conditions. Places like Lake Urmia in Iran, the Great Salt Lake in Utah, and Lake Natron in Tanzania are all known to take on this gruesome hue. For centuries, an event like this was seen as a terrifying omen. But the real cause isn't a curse, it's microbial. The transformation is usually driven by two types of organisms that absolutely love extremely salty water and bright sunlight: an algae called Dunaliella salina, and a family of bacteria known as Halobacteriaceae. Normally, the Dunaliella algae is green, but when the water gets too salty and the sunlight too intense, often due to drought, the algae kicks into survival mode. To shield itself from the harsh sun, it starts producing massive amounts of carotenoids, the same red-orange pigments that make carrots and tomatoes so colorful. As billions of these algae cells turn red, they stain the entire lake. At the same time, the salt-loving Halobacteriaceae bacteria also produce a ruby-red pigment to help them absorb sunlight, adding to the crimson effect. So, what looks like a lake of blood is really just a lake full of tiny organisms blushing to protect themselves from a sunburn. And at Lake Natron in Tanzania, the water is so alkaline it can burn the skin of most animals, yet these microbes thrive, creating one of nature's most extreme and hauntingly colored landscapes. We've unraveled moving stones and glowing tides, but our final phenomenon is one that science is still struggling to fully understand: ball lightning. For centuries, people have reported seeing glowing spherical orbs of light during thunderstorms. Ranging in size from a golf ball to a beach ball, they can hover, drift, and last for several seconds before silently vanishing or exploding with a pop. Because it's so rare and unpredictable, ball lightning has been incredibly difficult to study. For a long time, many scientists were skeptical it even existed. Now, the question isn't if it's real, but what it is, and there are a few wild theories. One of the leading ideas is the vaporized silicon hypothesis. It suggests that when a lightning bolt hits the ground, it can vaporize silicon from the soil. This cloud of silicon nanoparticles then reacts with oxygen in the air, slowly burning and creating a glowing orb. Lab experiments have even managed to create similar glowing balls using this method. Other theories propose it could be a self-contained bubble of plasma, microwave radiation trapped in a pocket of air, or some other exotic electrical event. The truth is, we just don't know for sure. Ball lightning might not even be one single thing, but several different phenomena that all look alike. It remains one of the last great mysteries of atmospheric science, a haunting reminder that there are still natural ghosts we can't quite pin down. From the deserts of Death Valley to the stormy skies above our homes, our planet is a stage for some truly spectacular events. For generations, we filled the gaps in our understanding with stories of spirits and monsters. But as we've seen, the scientific reality is often more elegant and awe-inspiring than any legend. The silent dance of the sailing stones, the ghostly flicker of a will-o'-the-wisp, and the alien glow of the ocean aren't supernatural acts. They're physics, chemistry, and biology, all performing in perfect, mind-bending harmony. Science doesn't take the magic out of the world. It shows us where the real magic was hiding all along. The more we learn, the more we realize the most wondrous thing on this planet is the planet itself. What other haunting phenomena should we investigate next? Let us know in the comments below. Thanks for watching.